Okay, area by double integration. Let's try not to have any gaps here and try to go through this quickly enough. So these first 5, I'm just going to do a sketch region bounded by the given lines and curves and express the region's area as an iterated double integral and evaluate the integral. So we're going to sketch, express, sketch it, make an integral, double integral, and evaluate. This is like the most important thing. Okay, so the coordinate axis and the line x plus y equals 2. So this means it's bounded by x equals y 0, y equals 0 because that's coordinate axis, and y equals 2 minus x. Because x plus y equals 2 is equivalent to y equals 2 minus x. And I'm just writing in that format because I think y makes it easier to quickly sketch. I mean, we don't even have to really do this because you can quickly see the intercept and then just plug in, yeah. You can tell pretty quickly, but hey, do it. 2 and 0, what y? So y equals 0 and y equals 2 minus x will be a limits of x equals 0. And it looks like x equals 2 would be the other one. Wait, that's what you get. 0 to 2 is x equals 0, and then you create x equals 2 is where it ends. Region. And 0, y equals 0 is the bottom, and y equals 2 minus x. 2 minus x, yeah, it's above. So bottom to top, yep. And it's dy dx. The area is just found like that. And you plug in what I do first. Yeah, I did in a different color just because it's separated, but that's the integral. And you can do this another way too, as I show real quick. You could solve this one and get the same thing, but you get 2 in the end as your answer for area. I guess you could say 2 square units, but whatever. It's 2. And then, yeah, because you integrate, this one is very easy to integrate. You have just y because it's dy dx, so y. So it's 2 minus x minus 0. Y equals 0, y equals 2 minus x. 6. You integrate that and you get x equals 0, x equals 0, blah, blah. Yeah. I don't think it's anything I would explain. You can see. Oh yeah, real quick. And also you can do it with x and y switched. This one's one of the easiest ones. You can do all these technically, but I think this one actually gives it very easily. You can do 2 minus y, yeah. You can do it like that. 0 to 2 minus y and 0 to 2. It's almost identical, basically. They're the same, but just 2 minus y instead of 2 minus x. But that one's a very easy one. Now it's time for us to get a little bit more tricky. We have a parabola and a straight line, so we're going to have to actually put in a little bit of effort. X equals negative y squared and a line y equals x plus 2 are boundaries. So y equals x plus 2 implies that x equals y minus 2. Yeah, x equals negative y squared, we're going to make it in terms of x. So we're going to do horizontal cross sections, so left to right. We get there. I sketched this twice because I don't know, I try to make these look accurate enough. But as long as you understand it, a very basic sketch is all you need. You can do it in like 10 to 15 seconds, just real quickly. 10 seconds, so it doesn't have to be perfect. So x equals y minus 2 is equal to negative y, so we equal to each other to 2 x functions. So y squared plus y minus 2 equals 0 because we add y squared. Then we have y minus 1 and y plus 2 is what can be split into those two terms. Y equals 1 or y equals negative 2. So that's our intersection points. When we plug them in, we get our x. So just do them for y equals, so x equals y minus 2. So 1 minus 2 means that, x equals 1 minus 2 when it's y equals 1. And so y equals negative 2. So basically you get negative 1 and negative 4 as shown. Negative 1, and negative 4, negative 2 are your intersection points. Shown here. X equals negative y squared. X equals y minus 2. So we're doing this with terms the x, so the outer part will be -2 to 1, whereas y equals 1 and y equals -2, 2, and y minus 2 is the leftmost and the right part is -y squared. So left to right. Then we evaluate it. So this one is also a fairly normal one. I show a lot of steps and I simplify down to 9/2 in the end. But this one especially, you could just do it normal ways and I'm sure you'll get your answers still. So yeah, make sure you get this. You can just look over and see that you can get what I did for evaluation. But this evaluation is just like the previous section, it's just setting it up a little slightly differently. It's this area same where you don't really have anything besides setting up the integrands. The curve y equals e to the x and the lines y equals 0, x equals 0, and x equals ln 2. Yeah, so this one gives us a bunch of boundaries. Now this one is basically telling you straight up how to do this. And it's really quick, as you can see. So y equals 0 equals e to the x. They'll never intersect. Y equals 0 and y equals e to the x. E to the x can never equal 0. It always is greater than 0. The function e to the x.
Oh, God.
Just a rule. And that's shown here because ln e to the x equals ln 0. That would mean x equals ln 0. And that can't happen. ln 0 is undefined. So, no intersection. So, we have x equals 0 and x equals ln 2. So, x equals 0.
Damn it.
It definitely won't happen here because e to the 0 is 1. We have y equals 0. So, it's just this region. This 4 sides.
Oh, damn it. Bitch. Ouch.
So x equals ln 2, x equals 0, y equals e to the x, and y equals 0. It's this region. And e to the ln 2 will be 2 as well. No doubt. Yeah, x equals 0 means that y, yeah, so 1. So y values change from 1 to 2, but that won't matter too much. Because y is the function. So 0 to ln 2 is your x values as shown, and 0, y equals 0, and y equals e to the x. You go from bottom to top, so y equals 0, y equals e to the x. Very obvious here. You solve it. Remember the integral of e to the x dx is just e to the x. So it's equal to 1 in that area. The parabola is x equals y squared and x equals 2y minus y squared. Okay, we have to do some work here, but it works. It does not, it's not extremely difficult. And I tried, it's kind of hard. It should be a little bit bigger looking, I think, but it's really hard to sketch this because it's two parabolas intersecting. Without software, it's not going to be as nice. So y squared equals 2y minus y squared. That's, you set them equal to each other. So y squared plus y squared, edit, and then you have minus 2y equals 0. 2y squared minus 2y, simplify down, equals 0. So divide it out. 2y times y minus 1 equals 0. 2y equals 0 or y minus 1 equals 0. So y equals 0 for that. Or y equals 1. Y equals 1, that means x equals 1 squared equals 1. And y equals 0 means x equals 0. So 0, 0, and 1, 1 are points of intersection between these two parabolas. And x equals y squared as before, and x equals 2y minus y squared is a monstrosity. But it's sort of like that. I mean, negative y squared is part of it, so you know it's going to be the opposite of y squared. Similar to negative x squared and x squared. But yeah, that's how it's. To, like, one of your solutions would be you could try to like, yeah, I don't know. You have to just. You could just kind of figure like how sketching would. Point being, okay, we're doing this. From this information, this graph and information, we get this integral. 0 to 1 is our y limits because we're doing it in terms of x horizontal cross section, left to right. So y squared is the leftmost, rightmost is 2y minus y squared. As shown because it goes there. That's left to right. And 0, 1 is y because y equals 0 and y equals 1. Yeah. The region is bounded by. You solve it through normal integration, and you get 1/3. 1 divided by 3 is your answer. And now we have 3 lines. Y equals 2, y equals x over 3. Or 1/3 x.
Ouch, bastard. Ow. Oh.
Okay!
Oh.
So the region here, I try to draw it better. It's kind of hard. I think this is more accurate here. 2 and 6 more distanced. The integral doesn't take long to solve. It's just I had these in a page because of this. Obvious. The trick here. We have y equals x and y equals x thirds. They intersect when it's obvious kind of, but from the graph especially. X equals 0. That's when they intersect. Y equals x and y equals 2 intersect at 2, 2. I think this is the best message just quickly. And y equals 2 and y equals x thirds will be x equals 6 because 2 equals x over 3. 6, 2. Y equals 2 is the horizontal line here, and so it's bounded by, it's a triangle bounded by 3 points basically. These 3 lines bounded by where they intersect. And the boundary, dx dy. So we do it with respect, so x, so y's are the ones. Oh, I see. No, we do it with x. The reason is x equals y and x equals 3y. Reasoning for this, I decided to do it x equals 3y when I would do this, and x equals y. Because that way we can go left to right and these lines both give it. If we wanted to do it another way, if we wanted to do it with y values, well, we'd have to do 2 double integrals, the sum of 2 small double integrals to get. But we can do it left to right because x equals this function, x equals that, cover the whole thing from left here to right. Covers the whole integration. Here. So it's 0, 2 is your y limits. 0 here, y equals 0, y equals 2. And x equals y, leftmost, x equals 3y, rightmost. Then we evaluate it like normal here, very quick. You get 4. The other method using the 3 lines with y equals, and y equals, you'd have to do a double integral and not a double integral. You'd have to add them. You'd have to do a summation because of how the whole region works. Finally, we do average value real quick. We have 2 examples of this. Well, technically 3. Find the average value of f of x, y equals sine x plus y over the rectangle here with 0 to pi values. And this one works. You integrate it. Sine of x plus y, like you can technically show a u substitution or not, but it's negative cosine x plus y. Because it's like x plus 1 or x plus 10 or whatever. Or, in this case, y plus it, because y is the one you're integrating with. So you go through this process and you eventually get 0. And the average, that's what your integral is. The average value is given by 1 divided by the area of the region here, multiplied by the integral area. This is like the area found, but you'll see the next one. And no matter what, we don't have to calculate it, but it'd be technically pi times pi, because it's a rectangle, length times width. It'd be 1 divided by pi squared times 0, but it's still 0. Doesn't matter what it is. Whatever the area is, it'll be 0 in that case. The average, the rectangle 0 to 10 is an x values and 0 to pi halves for y. 0 pi halves. You have this. X equals pi, x equals 0. Well, eventually you get that, so we set it up as 0 to pi. So in that case it was 0 pi because they were both set. 0 pi halves is this one because obviously you changed that. And you integrate it like before. You get 2 when you do enough integration. And so the area is pi times pi halves, which is pi squared over 2. 1 divided by pi squared over 2 times 2. You get 2 over pi squared times 2, so 4 over pi squared. Your final answer, 4 over pi squared is the average value. Then the final one, find the average height of the paraboloid. Z equals x squared plus y squared over the square, 0, 2, 0, 2. And we let the f of x, y function be just z x squared plus y squared, so we integrate that. dy dx, very similar to ones in the past with this type of setup. You do the double integral, you eventually get 32 thirds. And the area is 2 times 2, you could say 2 squared because it's a square, but it's 4. So 1 over 4 times 32 over 3 is what your average height will be from that formula from before, right here, average value. One divided by area times the integral, that's the area. So it's 3212 because 4 times 3 and 32 times 1. That simplifies down to 8 thirds, so the average height is 8 thirds. And that's all there is to that.